Hello and welcome to part 3 of creating a 2D platformer game using the Stride3D game engine. In this video, we're going to introduce coding patterns. Until now, we've been prototyping our game and haven't paid much attention to how we organize our code. Fortunately, we can use coding patterns to help us structure our code more effectively, making it organized, modular, and resilient to any complexity that might arise as we develop our game. When it comes to coding patterns, there are many to choose from, and it always depends on the type of game you're creating and the functionality you're working on. For example, if you're creating a turn-based game, you might want to consider implementing the command pattern, which enables storing and undoing chains of commands or actions in the game. You can also consider the observer pattern, which is useful when you want objects to be notified of changes in other objects, such as when an enemy needs to react to change in the player status. Let's take a look at our game and see which coding patterns we can implement. Let's open Visual Studio and we have our Ghost Hunter Control script here. So let's open this script. In this script, we can see right away that a lot is being handled here. Inputs, actions, and animations. We have the update animation frame, and you see there are lots of flags. So he's jumping, he's moving, and this script is handling all of these things. And this is not modular at all. In fact, we should always consider following the single responsibility principle. Now, imagine as we move forward with our game and add more and more functionality to the character using this script. How big and confusing will this become? Also, we have to ask ourselves, can this script be reused for different characters that share some of the same functionality? We can see the rabbit hole of many potential issues if we continue coding the game this way. The first important thing to consider from all of this is whether we want any of these actions to be used by other characters like enemies, NPCs or bosses. And yes, we want to keep our action options open to all characters in the game while still being able to create specific actions. To achieve this, we'll need to create a component that can be attached to any character entity and that can implement different types of states that carry out specific animations given certain inputs or not. These states dictate what actions a specific character can perform. For example, in the walking state, the character can walk right, walk left, and jump. Then when the character is jumping, the state becomes the jumping state, and in these states there are again specific actions you can perform. Maybe you want the character to do a double jump or initiate a gliding motion and so on. It's important to note that states are responsible for transition to other states, and this is what is called a finite state machine coding pattern. It's a great way to organize what the character can do, making the code modular and reusable. For inputs and animations, we will be using something like the strategy coding pattern, which allows us to use and switch between different algorithms at runtime while maintaining a consistent structure between them. So in conclusion, we want to organize our code in a modular way so it can handle inputs, animations, and character actions. And for the character actions, we will use the state coding pattern, and for the other, we will use something like the strategy coding pattern, and we will implement everything so we can achieve the same functionality that we have at the moment. And that's it for the intro of this video. I hope you have a good understanding of what we aim to achieve with the coding patterns we'll implement. If anything's unclear, stick around because it will make more sense as we start implementing the code. So cancel your appointments, grab a cup of coffee and open your code editor and let's dive in. We will now create some folders so we can properly organize our code, and for that we are going to open Visual Studio. So going to our Solution Explorer and right clicking in our project name here, we are going to add a new folder, and this folder is going to be called the character. And inside this folder we are going to create a new folder, and this is going to be called the animation. we are going to create another folder. This is going to be called the controls folder. And we are going to create another one. It's going to be called the states folder. So we have our animations folder. This will contain all the code relating to character animations. And we have the controls folder. This will contain the code relating to the controls, or the way we can control our character. And the states folder, where we are going to put all the states of our characters, like walking state, the jumping state, the idle state, and so on. And this relates to the state coding pattern that I've mentioned before. So inside the characters folder, we are going to create a list of character types. So let's add a new class. And let's call it character types. So character types. And this is going to be a public enum. So we have our main character. So going to be the main character. We can have a ghost, and we can also have zombies. And we can add all the types of characters that we will have in our game. So let's clean this up and let's save. And this is okay. For now, we will only be using the main character type, and this is more than enough for what we need for now. So let's continue. So let's now create our character class. So this is going to be a sync script, and let's name it the game character. Let's make this public, so it's going to be public, and it's going to be a sync script. And this implements some methods, so let's check out what it does. So of course, this sync script, they all have the update method, so we will be needing that. And let's leave it like this, and let's clean this. And now let's create the character properties. So you can understand what we are trying to do. This sync script we will attach to any character that we create in our game, be it the main character or enemies or NPCs or whatever we want to create. This is a way of having this functionality modular, as you know. So this is going to be, the game character will be a component that will be adding a lot. And this we can add directly the Stride3D Game Studio or via code. So let's continue creating this class, and we are now going to create some attributes that will be common to the game characters. So let's do a float, and this will be the health. Okay, and we can set a default value of 100, and let's do also, yeah, that's it, public float speed, and we can set this to 3, like that. And also have to provide a character type. We have our enums that we've created before, so this is going to be the character type. So character type, and we'll also need to define the controls type, but we don't have a list of what types of controls, so let's create that now. So going back to the controls folder, we are going to add a class inside of this folder, and it's going to be called control types. So control types, and again we are going to make this a public enum. We're going to have a keyboard type of control, and we're going to have a none, because we might have characters that don't require to be controlled by a player, such as enemies or NPCs, and the behavior of those characters will be automated by code. So let's just leave it like that, and let's go back to our game character class, and let's continue. So this is going to be the control type, control type, there it is, and this is going to be control type, and that's it. So going back to our Ghost Hunter controls, we can see that we have sprite component that we are using, and there's a character component that we are using as well. And also we are going to need these in our game character class. So let's go back to the game character class and let's continue adding attributes here. It's going to be the sprite sheet, and let's just call it sprite component. And also we need the character component, so let's add that. So that will be the character component, and we can call it character component. So again, these character type and control type will be available for us to control in our Stride3D Game Studio. So when we attach this sync script to any character, from there in the Stride3D Game Studio, we can decide which character type it will be and what control type it will have. So let's continue. So going forward, we will need a way to set the type of animation that our character will have. For that, we are going to create an attribute that is going to be called of type animation, and it's going to be the current animation. And it's not animation, it's animation. Okay, so this class is not created, and we will have to create this base class in our animations folder. So let's do that now. So let's add a class in our animations folder, and we are going to call it animation. And this is going to be a public abstract class. So let's change this to public abstract class animation, and we are going to have some base methods here. So, and this is going to be a virtual method, and this allows us to change this method for every animation case that we need. This is going to be void, and let's say that this is the play jump animation, and it's going to take in the game character, and we can call this the game character, and also it's going to take a direction, and this is going to be the direction. And don't forget the opening closing brackets here, otherwise this won't work. So the direction, so you can know, is from Stride, so it's not a list that we've created. We are getting this from the Stride module, and this works fine for us. So we are going to use this direction. Because of the play jump animation, as you know, when the character is jumping in midair, it can change direction. So that's why we are using this direction here. And let's continue. So we are going to create another virtual method. So public virtual void, and this is going to be we can now do the play walk right animation. And again, we are going to put in the game character, and that's it for this. And we're going to create another one. This is going to be the left animation. So we now have a method that plays the walk right animation, and we have a method that plays the walk left animation. And we still need another one for the idle animation. So the public virtual void and play idle animation, and it's taking in the game character, and it's also taking in the direction. So the character, when he's in the idle state, he can either be facing left or right, so we need the direction in order to set each type of animation. And we need another method, so let's do a different accessor. So protected, and this is going to be void, and this is going to be the update animation frame, and again it's going to take the character and also the direction. And this is going to be let's go back here to our Ghost Hunter controls. This is going to be this method here that we had before, and this method is in charge of cycling through frames and playing the animation. And let's go back to our game character class that we were working on. And of course, the current animation attribute, we can now get the proper class reference. And there you go. We now have the current animation. And we will also need something to store the state. And this will be the state context that we talked before. This will store the current state that the character is in. And this class will be used to perform the proper actions for the state that is in. For example, if it stores the walking state, then it will implement the walking state methods like walking left, walking right, and jumping, and so on. So let's create this attribute. It's going to be a public character. We can call this the character state, and we can call it current state. So again, the character state we don't have at the moment, and I guess you already know where this will go. This will go into the folder, the states folder, and let's create this class now. So let's add a class, and let's call it the character states. And again, this is going to be an abstract class, so we'll make abstract class. And we are going to need the game character class. So let's create an attribute for that. And this is going to be the game character. So character. This is going to be a private set. So it means that it can only be changed from inside this class. Let's also create another attribute here, and this is going to be the direction, and this is going to store the current direction of our character. And this one we are going to leave it open to be set from anywhere. Let's also make it have a default direction, which is going to be the right side. And next we'll need to create a method to initialize our game character class. So let's do that, and this is going to be a public void, and we can call this initialize, and it will receive the game character as parameter. And let's attribute the value of character to our character attribute here. And next we are going to create some methods that are needed to handle our states. So let's do that. And we are going to have a public abstract void, not update, but enter state. So this will be ran when entering the state. Next, we are going to have another one. So it's going to be, this axis state, and another one that can be update state. That's it. So IntelliSense is working very well because he knows what is supposed to be happening. And next we are going to define the actions that can be performed on states. So here we will always have to add all the actions that can be performed in any state. These methods are going to be virtual methods, so let's add them now. And the first one we can do is move left. So every character will probably be moving some side or another. So let's do move left first, and we will also set our current direction to direction left. And let's create a move right, that's it. And also set the current direction to direction right, and that's okay. Let's continue. So there is no move up, but there is a jump, so jump. And actually this one will be empty, just leave it like that. And also I forgot to mark this as virtual. So public virtual void jump, and let's just copy this, and this is going to be the idle. And next we will create a method that will be used for the state transitions, and this is going to be called the change state. So let's make it protected, and let's call it change state. And this is going to be going to receive a character state, and this is going to have a new state. So as I said, this is going to handle the transitions. And let's do character. So current state is going to run exit state, because you might need to perform some cleanup or some steps before exiting the current state. So that's why we are calling the exit state here. And now we are going to set the direction. So the direction is going to be the current direction, and this is persisting the directions between the state transitions. So if the character is facing a direction, when it transitions to the other state, it maintains the same direction. And let's continue. And now we are going to set the new state in this character state. And of course, we will need to play the new state. So current state dot enter state. So when a transition is made, the change state method always needs to be called. And if there are anything to do in a last state, like cleanups or something that is needed, is executed in an exit state. And then we are setting the direction, as I explained before. And then we are attributing the new state. And within the new state, we are going to call the enter state method that can perform any initial state animations or whatever is needed. And that's it for our character state base class. And let's just clean this up. So we have the broom to clean, and this looks good for now. And let's continue to our game character class. And of course, we can now reference this class, and there it is. Next, we will create a series of attributes that will contain the states that we will then initialize every time this class is instantiated. So let's start with the idle state. So let's make this a character state, and this is called the idle state. And this is going to be set within this class only. Next, we are going to create the walking state, also private set. And lastly, we will add the jumping state. So jumping state. So every time this script is attached to a character entity, be it the main character or enemies or boss, then we will need to initialize the states that we will be using throughout. And for this, we are going to create an initialize method. So let's create it right below the update methods. And this is going to be privately called. So we can call it initialize states, and we are going to initialize our states. But there will be a problem because we don't have these states created yet, defined yet. So let's create them now, and let's go to the states folder. So we are going to create a class for the states. We are going to create 3 classes. So it's going to be the idle state class, the walking state class, and the jumping state class. And let's go ahead and do that. So we can start with the idle state. And for now, we are just going to make this a public class. So public, and we will inherit from the character state. And now we can implement the abstract class, and there you go. We can leave it at this for now. So of course, this includes the enter state, exit state, and update, but we also need to implement the actions that we can do within the idle state. So if the character is stopped, what can we do? We can move to the left, move to the right, and perform a jump. And of course, if we move, then we will transition. The class should transition to the walking state. So we are not going to implement this right away, and we are just going to create the rest of the states that we need, so then we can continue implementing our game character class. So let's do that and create another state, and this is going to be the walking state. And again, the same thing. So this is going to be a public class, and it's going to inherit from character state. And let's implement this. Let's clean up the class, save, And let's create the jumping state. So let's add another class and jumping state, same thing. Let's inherit from the character state, implement the class, and that's it. We have our idle state, our jumping state, and our walking state. So let's continue. Let's go back to our character state, and now we can initialize the states, and this will be initialized in the starting method. So let's create the start method just so we don't forget. So public override void, and here it is, the start method, and we can delete this here. And let's continue to our initialize states. This is so wrong, and there it is. So now we can initialize our state. So idle state is going to be equal to a new idle state, like that, and we need to initialize the idle state. So idle state dot initialize, and it's going to be initialized with the reference to this class, so to this script that is attached to a character entity. And let's continue. Let's do the same for the other states. So is the walking state, and it's already telling us what to do, and we need to initialize as well, and this one as well, and there it is. And now we can go back to our start method here. That again, the start and the update are part of the sync script. And let's go back to our start method, and since we are here in the start method, we are going to also initialize the sprite component and the character component, just as we had done in our Ghost Hunter controls. So here it is. So these things here, we can actually copy them and go back and paste them here. And of course we need to change the name here. So this is the sprite component, the character component, and they are being initialized here. And now we can call the initialize method for the states, and this code here is going to be initialized there. And now we would leave this at this point and go back, because we still need to add another attribute here, and this is going to be the control, because we need to know which type of control is added to control this character, if it is a controllable character like the main character. So let's create an attribute, and we are going to create iControl, and we are going to use the iControl type, which is not created yet, but we'll create it next. So this will be the current control, and let's set it as a private set. And now we need to create this interface, because this is going to be the interface that accepts what controls will be added to this character. So we are going to add this interface to our controls folder. So here it is, and we are going to add a class, and this is going to be called iControl. It's going to be a public interface. So interface. Now we are going to define what actions our controllable character can do. And with the controls, we are going to implement something like the observer pattern. And this is going to use events and actions that are inside the .NET framework. If we type event here, and we can see that this is a keyword, also action, it's a type that we can use. And we are going to call this event the onMoveLeft. And we are going to create another one called onMoveRight, and we are going to create another one that is going to be called onJump. And again, we are going to be calling this onIdle, and we are going to create a method that handles the input. So this is going to be a void method, and it's going to be a handle input, and there it is. So let's clean this up. So just to make it clear how this is going to work, we are going to have a keyboard control sync script that is going to inherit from this interface and is going to implement these events here. And somewhere we will have a game character class that will register to these events. So every time that it listens to an event, like on move left or on move right, it will execute some actions like move left or move right. So let's implement this next, and we are going to add a class to our controls folder, and we are going to be naming it keyboard control. We are going to make this a public class, and it's going to be a sync script, and also is going to inherit from iControl. And we need to implement this interface, and also need to implement the sync script methods. So inside the handle input class, we are going to define what triggers the events. So let's do that next. So if the input is key down, and we're going to make this keys, so keys dot left, then we are going to on move left invoke this event. And there seems to be a problem here. Let me clean this up. And I think he got something from the Windows form, which is not what we want. It should be stride input. Yeah, that's it. And next we are going to do the same for moving right. And let's just copy this. And we just did the same for the jump. So if the key pressed is space, then it will be the jump. And next we need to trigger the idle. This will be when the keys right or left are released. Then we will trigger the on idle event. And lastly, we just need to run this handle input method. Let me just put this up here, and that's it. So we already have our control set up, and we can go back to our game character class and continue working on it. So now we can reference this from the controls folder, and now we can make this class listen to the keyboard control and perform the state actions. So let's do that. Let's go down here below the initialize states, and we will create a method that will be called the attach input handler. And again, this will be used in characters that are controllable. And this will take in the keyboard control that we just created. So keyboard control class, and we can call it keyboard control. And now, because we defined our events as actions, we just need to call the current state that is related to the action. So this will make sense once I show you the code. So let's get the keyboard control, and if on move left action event is triggered, then we will set up a lambda, and this will be the current state, and this will be the move left, which is the corresponding method. So if the keyboard control on move left trigger is set, then it will play out the move left action that is defined in the current state that the character is in. So imagine if the character is walking, then move left will be the walking left animation, and the character should move left. If the character is jumping and is during the jump, then the move left in that case will only be the character moving left, but not playing the animation of walking. So this will be dynamically set by the states. And let's continue. We are going to do the on move right, and that's it. And next we are going to do the on jump, and that's the jump, and the idle, and that's the idle, and that's it. As our game progresses, then you can imagine that we will have different movements and actions that we will need to update in our keyboard controls class and our eye control class. So we need to update this and update this method here every time that we need to enhance our character with new movements. And now we can go back and have a look. So we have our update method here that is not doing anything at the moment, but as you remembered before, in the character state we have an update state method here, and this update state needs to be ran at every frame, because this is where we might need to check some condition to transition to another state. So let's run that in our update method. So going back to our game character, and here we are going to get the current state, and we are going to run the update state, and that's it for that. And now let's look back, and we have our character type and we have our control type. Now imagine that we are setting up our character via the Stride Game Studio, so we need a way to initialize the character type and also initialize the control type. So, and this is when we are setting up via the Stride Game Engine Studio. So for this we are going to create two methods here, one to configure the character type and another one to configure the control type. So we will call this the character configurator, and we need to pass in the character type, and we will need another method to the controls to set up the controls, and this will be the control selector, and we will pass out the control type. And let's create these methods and this one, and let's go down here, let's put them at the bottom, and let's implement this switch. So switch, and we are going to put in the control type, and we are going to implement this switch to check which control type. Okay, there is some issue here, and I think it's again this is not getting the correct reference, and let me change this. Yep, of course. So this is control types, and actually I think this should automatically fill in the cases. No, okay, there you go. And we are going to set the current control, and we are going to get the keyboard control component. So let's use the get method of the entity, and this should be like this. So keyboard control like that, and we should also attach the input handler, and here we should pass in the current control, and this is giving off an error because it doesn't recognize the controller, so we need to set it as a keyboard control, and there it is. And of course this can be used for automated characters, and for the default case we will leave anything. We could put the controls, the keyboard control, but you can decide what to do then. And now let's do the character configurator. So character types, and let's create a switch here, and this is going to be the character type, and there it is. So now we should address the animations, because we've pretty much done the control part and we have the states, but we have not started working on our animation for the main character. So in this case, if the main character is selected, then we should set the animation to the main character class animation. So we will need to have a set animation method here, and this will need to take in an animation type of class. So you remember the animation class that we created here, so it will need to take a class derived from this class, and we can go ahead and create a class right away that will be for the main character. So this can be called the main character animation, and let's make this public, and this should inherit from animation. So animation, there it is, and we will need to implement this class. And let's clean up, save this, and let's go back to our game character. So now we need to create this method, and here it is. This here, the set animation method, simply sets the current animation. So we will need to get a class from animation, and this will be the animation strategy. So we can call this animation strategy. And now we just need to set the current, sorry about that, animation to the animation strategy, and there it is. So next we need to pass in the animation class. So let's create the new main character animation, and we need to open and close parentheses there, and that's it. So let's set the state for this main character, so the initial state, and that will be the idle state. So current state is going to be equal to the idle state, and we need to enter the state. So current state, enter state, and that's it for our main character. And this is it. So this is what we need for the main character. If we were to have a ghost, then we would set the animation for the ghost, and of course we would need to create an animation derived from the animation class. It could be called ghost animation, and zombie, it could be called zombie animation, and you get the picture. So pretty much you would set what this character would do, and this can be all set from the Stride Game Studio. Of course, you might choose to just code everything from Visual Studio and not actually use the Stride Game Studio. So let's move on now, and we can close this. And we can see that our character configurator and control selector will initialize, and with the parameters that we have done there. So now we can go and implement our main character animations. So this will implement the animations just like we had in our Ghost Hunter controls. So we had this update animation frame, and we had the frames here and the animation timer, and all of these will be implemented inside the main character animation. And let's go ahead and implement this. And to have everything organized, I'm just going to paste some fields. These are the frames, so this is organized in these fields. So these are the walk right frames, and these are the walk left frames that are inside an int array. And next we are going to get these fields here. So let's copy these, and we are going to paste these here, and we are going to have to get the direction, and the default direction is going to be right. Now I'm going to paste the improved version using these fields that we have here, and this is doing the same that it was doing in the Ghost Hunter controls, but is a little bit better organized because we have those fields for the values of the frames. So let's continue, and now we are going to add the methods that play the animations. So we are going to have a method to play the idle animation, So this is going to be a public override void. And if you remember, we've created this. So we have the play idle animation here, and we are going to implement our own solution here. So this is going to be the game character, and we are going to get the sprites component. I think was the name that we gave it, or not. Let's check. Sprite component. Yes, we should have the sprite component. Yes, and we are going to get the current frame, and this is going to be equal to direction is equal to direction dot right. Then is going to be the jump right frame, otherwise it's going to be the jump right jump left frame. And that's it for our play idle animation. And let's create the play jump animation. So public override void and play jump animation here. Now we are going to implement. So again, and now we will override the method for the walking left animation. So override void, and we have the walk left. And let's go ahead and do the other one. So right void, and that's the other one. So this simply we are going to update the animation frame, and we are going to pass in the game character and also the direction, which is going to be the direction left. We are going to do the same, but here we are going to pass the direction right. And that's it for our main character animation. And now we have our animations. So inside of the states, we will then have the capacity to play these animations, and these will be played from the current animation that we have selected. So if we have the main character animation selected, and then we can play this animation for the character. So now we are ready to implement our states. So let's go back to the idle state and let's start implementing our idle state. So we are going to start with the enter state, and in the idle state the character should be stopped. So we are going to make sure that the character is stopped by getting the character component set velocity to 0. So this takes in a vector 3 and 0, and this, let's make sure that it's from Stride, and this is 0 with a capital Z, and that's it. So next we need to play the character. So here we are getting the current animation, which will be the main character animation, and we can play the idle animation, and we can get the character, and also we can get the current direction. So this will play the character in the current direction, which will be the default direction right, and this is it for our enter state. Next, so what can we do in our idle state? Well, we can move left, for example. So let's override the left method. So void move left, and if the character starts moving left, walking left, then it will change to the walking state. So we need to call the change state. So that's a method that we have included here in this class. So we can change this to the walking state. So you remember that we initialized all the states. So we need to get the walking state, and that's it. Next, we need to move left in the walking state. So now in the walking state we can move left. So let's get the character and let's get the current state, and let's move left like that, and that's it for our move left. And we can go ahead and create the move right. So this here will be right, and also if it's walking right, then it's in the walking state. So now we are going to put this like that, and we can also, from the idle state, we can also jump. So we need to also override the jump method. And of course, if the character starts jumping, then it should transition to the jump state. So let's change the state, and the character should go to the jumping state. And of course, we need to jump. And lastly, we need to implement the idle method. So public overrides void, and we have the idle method, and this will be used whenever the player releases the keys for walking right or left. So let's implement the animation. And we will not be implementing our exit state or our update state. So we can leave it like this, or we can delete it. You can decide what to do. But for the rest of the idle state, this is perfectly fine. So let's save. And now we can go on to implement our jumping state. So let's open our jumping state. We have to implement firstly the enter state. So let's do that. When the character enters the jumping state, we need to play out the play animation. We need to play the animation, so this will be the character, and we will get the current animation, and we will play the jump animation. And this takes in the character and the current direction. And then we can make the character jump. So character, and we go to the character component, and we invoke the jump method. So next we can implement the move left, because the character can move while it's in the air. So this is going to be the public override, right? And it's going to be the move left method. So here we have to set the current direction, and we'll set the direction to left. So this is direction. We will also need a direction value to pass into the set velocity. So this is going to be a vector 3, and we can call it move direction. And for now, this will be just 0. So the move direction and the axis will be less than equal to the character speed. And this is the speed that we have defined up here in the game character class. And now we can set the velocity, so to make the character, the entity move. So that will be the character component, set velocity, and move direction. And lastly, we need to update the animation if the character is still in the air. So we'll add an if statement here, and if not character, and this will be the character component with the flag is grounded. So if the character is still in the air, we are going to play the jump animation. So character, current animation, and play jump animation. And we are going to pass the character and the current direction. And that's it for our move left method. And we will do the move right, and we can actually copy this one and just change everything to right. So this will be move right. Here we will set to right. This is okay. So move direction, and the animation is the same. And this is okay. Next we will need to play the idle animation when the character lands on the ground. So we will override the idle method, and we simply check if the character is grounded, then we change state to the idle state. So that's pretty much it. So if character component is grounded, then we just change the state, and here we will pass in the idle state. And that's it for the idle. And next we will override the update state method, and this also will check if the character is grounded and if it needs to change to the idle state. So let's override the update state. And we can just copy the code just like that. So also we can put here the jump method in case that you want to implement a double jump. So allow for a double jump. We actually had the update state here, and exit state we won't need it for now. So this is it for the jumping state, and let's save this and let's implement the walking state. So let's open the walking state class, and the enter state we are not going to implement it, so we are going to the move left. So let me see if I can public override void move left, and let's also do the move right and also the jump and also the idle, and these are the ones that we are going to implement. So let's start with the move left, and this reminds me that we might have a potential error in the jumping state. So let's go back, and actually we do. So the move right here, because we pasted, is plus equal. So because we are incrementing in the x-axis, you want the character to move right. So move left is we subtract, and move right we are adding. And we need a variable for the move direction, so vector 3, and this is going to be the move direction, and we'll put it 0 here. So vector 3 0, and this vector 3 is using the Stride3D reference. And now we can set the move direction x-axis to be less than equal to the character speed, and we will set the velocity to make the character move. So character component, set velocity and the move direction, and we have to play the animation, of course. So character current animation and play walk left animation, and we need to pass in the character like that. And that's it for our move left method. And now we are going to implement the move right. So let's copy all of this and let's paste it here, and we need to change this to right, and let's change this to be plus equal to move the character to the right side. This will be the same, and this we need to set to right. And that's it for the move right method. We are now going to implement the jump method, and this is going to be simple. We just first need to change the state. So change state, and we are going to get the jumping state like that, and we are going to evoke the jump method of the current state. So character current state, and we are going to call the jump method, and that's it for our jump method. For the idle, it's even simpler. So let's delete this, and we just need to change the state. So change state, and we are going to pass in the character idle state like that, and the exit state will not be used, and the update state also will not be used. And that's it. So we have our idle state, we have our jumping state, and we have our walking state. So the walking state has these methods that make the character move and also plays the correct animation that is set for this character. And this we also transition to the jump state, and we can transition to the idle state. So the next thing that we need to do is to set up all of this in our Stride Game Studio. So, and actually we have the Ghost Hunter controls here, but we don't need this script anymore. So we can safely delete this script. So let's go ahead and delete this script. And I'm just going to clean the solution and rebuild the solution, and this should pick up any errors if there are any, and all was built successfully. That means that every reference is should be working okay. Anyways, when we play the game, we will see if there is any error. So let's clean this up and let's save again. And now we can go back to the Stride Game Studio, and we'll actually close the Stride Game Studio. And we have to be very careful to select the don't save, because if we save, it will override all the changes that we've made on Visual Studio. So let's just close this and let's open it again. And it should get all these new classes and everything that we've done here. And I think it's already warning us that something is missing, and that's probably the Ghost Hunter controls that we've deleted. So let's go ahead and close this, and let's click our character and go down here. And as you can see, the Ghost Hunter controls is not available, so we can delete this. And now we can add a component, and let's add a script. And we have our game character script that we've created. So let's select the game character script and go down. And as you can see, we have the health value and speed value, and also we can select the character type here. So we are going, it's already set to main character and it's already set to keyboard, but we can change this to ghost or zombie or whatever that we want to create to this character here. And just to explain, this is a feature that I added here to be so we can be able to attribute what type of character this character will be, but we can also configure this via code. For example, if you are creating enemies, if you are spawning enemies, then you want to have the ability to create characters from code. So to do that, we most probably will need to add a configuration method to the game character. So the game character class that defines what type of character and the states and everything, the animations, we can have, for example, a configuration method that you can call in the code and set up which type of character you want to create. So if you want to create, imagine 10 or 20 enemies, you can do so using this class in the configurator. So let's go back to the Stride Game Studio. We now have our main character set up and our keyboard set up. And also, if you noticed, we have the sprite component and the character component here, and we actually don't need to have this here. So what we can do is go to our Visual Studio, and we are going to just make the sprite component private and also the character component private. And we can also make the current animation private, and the rest we can leave it as it is. So we can save this, and again we need to, okay, it's already detected and removed it. That's great. And now we can save this, and we can go back to Visual Studio, and let's run the game from the Visual Studio and see if everything is working okay. If there are any bugs, then we'll catch them at this point. And we are getting a bug right away, and this is absolutely normal because we did not attach the keyboard control to our character. So let's go back to the Stride3D game engine, and let's add the component. Let's go to scripts and let's add the keyboard control, and that's it. Now that it's added, we can go again. We can save this and we can go back to Visual Studio and play the game again. And we are getting the not implemented exception on the update state. And this again is perfectly normal. So what we need to do is just remove the throw keyword here. So let's stop the execution. We can leave it empty like this and like this. And maybe we can implement something here later if we need to. And of course, we need to go to the other states. So the idle state, the jumping state, and there's another one here. I have to delete this one. And the walking state, again, we can delete this one and these two in the end here. So let's delete these ones. Let's delete this one as well, like this. And I think that's all. Okay. and let's run again. And there seems to be a problem because the character is always in the jump position here. So, but the rest is working okay. So that's the only problem. When it lands, it should be set in the idle position. So let's go back and try to figure out what we did wrong. And the problem is we in the main character animation, so this was probably IntelliSense auto completing. So we will just change this to idle and change this to idle because we were setting the jump right frame. So we will showing the image of the character jumping in the play idle animation. So let's save this and let's play the game. And there you go. So everything is working just as before, but now we have everything organized in our states. And as you can see, everything is working just fine. So we can navigate our way around just as fine. And this actually, the character actually seems very slow. So let's go back to the Stride Game Studio and let's go back to the game character here and let's set the speeds, and we can make the default speed to 5 in the game character because that's too slow anyway. So let's go back here and let's set this to 5, and that looks okay. And let's play the game again, and we actually need to change it here. So let's make this 5, save this, and let's go back to Visual Studio. And now it's much faster. So just to show you guys how we can add another state to a character, I've created a patrol state and here it is. So this is the states folder and we have the patrol state. So this state is very simply a patrol action. So the character will go back and forth between the walls. So looking back here on the game studio, we have a second character that I've created, and this character is going to go side to side, so back and forth between these two walls, and it's going to be patrolling. And actually I've added this to the ghost type, and it doesn't have any control type. Is going to be automated, so going back and forth. And if we go back to the codes and if we go to our game character, we can see that we have a patrol state that we've added here. Also here we are initializing the patrol state, and then it's set in the character type. So we've set this in the ghost type, so the ghosts will be patrolling back and forth. And we are setting the main character animation because we don't have a ghost animation yet, but it's starting out with the patrol state, and this state doesn't transition to any other state, so the character will be continuously patrolling side to side. And this is it. So let's have a look how this is going to play out. So we have our main character here, and this will be the character that will be patrolling, and we can see that the character is patrolling back and forth. So when he hits the wall, then he goes back and he comes back like that. And if we stand in its way, then he doesn't go forward because he's checking the collisions with the walls. And that's how easy it is to have a different state with the character and define different characters with different states. And this is it for this tutorial. It was a long one, so I hope you have learned something with this. And of course, the code that I've presented could be better, and I'm sure that you have seen lots of things that can be enhanced. And remember that coding patterns can be applied for many different situations and can be adapted for many different games and situations that you have. Thank you very much for staying with me through this video. And remember to subscribe and leave a like and any comments that you have. So thank you very much and see you next time. Bye bye.